Here's our second application problem involving parabolas. Example 9 says a bridge is built in the shape of, and I think I left some words off here, but in the shape of a parabola with a maximum height of 25 feet above the water. Choose a suitable rectangular coordinate system and find the height of the arch at distances of 10, 30, and 50 feet from the center. So let's make a grid here, and then here is my parabola or my bridge. So I know that it has a maximum height of 25 feet. So this ordered pair then would be 0, 25. And it doesn't say here, but it does show here that my bridge is 120 feet across. So that means this ordered pair would be 60, 0. We really don't need this one, but this is negative 60, 0. All right. So looking at my formula sheet here, my parabola is opening up, or sorry, opening down right here. So I'm going to use this formula right there. So I'm going to write that on my paper. All right. Now I do know my vertex. My vertex is my H. Okay. So I can put that in my formula. H is 0. Y, or I mean my K is 25. And I'm going to clean that up a little bit. X minus 0 is just X. We've got X squared equals negative 4A times Y minus 25. And so what I have left to find is my 4A, or really, I'm just going to find negative 4A. And so we can do that by using one of these two ordered pairs. This is my X and my Y, so I'm going to plug that in for my X or my Y. So X is 60, so we've got 60 squared. And then 0 for my Y minus 25. So 60 squared is 3,600. I am just going to simplify this right here. So this is negative 4A times a negative 25. I can multiply these together, but I just really want to solve again for this negative 4A portion. So if this is all being multiplied, this means I can divide over my negative 25. And so I get negative 144 equals my negative 4A. So I'm going to take what I have found, negative 4A, and I'm going to replace it right here. So now this equation becomes X squared equals, instead of negative 4A, we found negative 4A to be negative 144, and then Y minus 25. So this is my equation in the form I want. Okay. Okay, that is this in this form. Now, when I come back up here to the top, I want to find the height of the arch at distances of 10, 30, and 50. So these right here are representing what? My X or my Y? I want to find the height at distances of 10, 30, and 50. These are representing my X values, right? Find the height. So my height is my Y at distances. We're going distances out, distances of 10, 30, and 50. So you're wanting to see when I go out 10, what is that height? When I come out halfway to 30, what is that Y? When I come almost to the end of here at 50, what is my Y? You can use this equation, no problem, and put in 10, 30, and 50 into the X right here. But what you're going to have to end up doing is solving this equation 3 separate times for Y. So the easiest thing to do is to take our equation and solve this for Y, and then it's just plugging in values. So if I want to solve this for Y, I could distribute that 44, but the easiest thing to do is the opposite of distributing negative 44 is to divide. Right? Because that's negative 144 times Y, negative 144 times 25. So the opposite would be just to divide that over. Can't do anything here. So I've got X squared over negative 144 equals Y plus Y minus 25. And then lastly, add your 25 over. So Y then equals X squared over negative 144 plus 25. So now take this and replace this X with 10, with 30, and with 50. So calculator work. So let's see, we have 10 squared divided by negative 144 plus 25. That's about 24.3 feet. Is that what we're in? Feet. And an arrow up, grab my 10, change it to a 30. We got 18.75 or 0.8 feet. And then lastly, change that to a 50. 7.6. So these are my answers. And that should make sense that it's going down, because when you look at this diagram here, this bridge is going to get shorter and shorter. So at 10, it's a little bit shorter than my tallest of 25, but not by much, 24.3. Then halfway, it's at 18, and then at 50, it's pretty short at 7.6.